and welcome to today's video on powers and exponent rules, part 2. So last week we learned about multiplying powers, dividing powers, and taking powers to powers. This week we're wrapping up our powers and exponents rules by learning about the zero exponent property and the negative exponent property. So in some ways what we're doing this week will feel very weird, right? Like it doesn't make sense to take a number to a negative power. We can't multiply a number negative times. But on the other side of things, these power properties actually really complete all the other rules we learned about last week for powers and exponents. And I'll try to make those connections in this video today, in addition to giving you some examples. So the two power properties, we're going to start with that zero exponent property. Okay, so the zero exponent property is really quite simple. It says a, which can be any number except for 0, positive, negative fractions, a to the power of 0 is equal to 1. Just the number 1. So like 89 to the power of 0 equals 1. You have to put in parentheses, but negative 218 to the power of 0 equals 1. Pi to the power of 0 equals 1. Any number to the power of 0 has the value of 1. People often think it would have the value of 0, so we're going to look today to talk about why that is. So we're going to show why 3 to the power of 0 equals 1 two different ways. First, we'll examine the pattern by completing this table. So here I have my power 3 to the power of 4. So in expanded form, we know that means 3 times 3 times 3 times 3. Okay. Then I have 3 to the power of 3. 3 times 3 times 3. So my change pattern is what's happening there. I mean, you could describe it as like I'm getting rid of a 3. But what am I really doing? To get from 3 times 3 times 3 times 3 to just 3 3s, I'm dividing by 3. Right? I divide by 3. That one cancels away to 1. Okay, then I can continue to here. 3 to the power of 2 is 2 3s. Again, how do I get from 27, this has a value of 27, to 9? I divide by 3. Okay? Then again, 3 to the power of 1 is 3. That has a value of 3 itself. How do I get from 9 to 3? I divide by 3. Thus, we don't really know, until me telling you the rule, what 3 to the value of 0 is, but we can continue this pattern. We should be dividing by 3. So what is 3 divided by 3? Right, 1. Okay, so 3 to the power of 0 has a value of 1. So that's one way of seeing how this zero exponent works. We're completing that pattern. When we drop down an exponent, we're dividing by the base once. And then we can also see it using the quotients of powers rule. So last week we learned that whenever we divide a power by a power, if they have the same base, we can keep the base and subtract the exponents. So here we have 3 to the power of 4 divided by 3 to the power of 4. The quotient of powers rule says that's equal to 3 to the power of 0, because 4 minus 4 is 0. However, if I go into expanded form, 3 to the power of 4 is 3 times 3 times 3 times 3. And of course, it is the same again in the bottom. So now I have 3 times 3 times 3 times 3 divided by 3 times 3 times 3 times 3. We know that anything divided by itself is equal to 1. Right? These 3's cancel away to 1. These 3's divide away to 1. These 3's divide away to 1. These 3's divide away to 1. And we get that 3 to the 4th divided by 3 to the 4th has to be equal to 1. And 3 to the 4th divided by 3 to the 4th is equal to 3 to the power of 0. So 3 to the power of 0 has to be 1. Awesome. So now in the Edpuzzle, I'm going to ask you the value of some of these powers. All of them will have an exponent of 0. Thus, the value is going to equal 1. So that's the answer. Awesome. Now let's look at our second property, This is the negative powers property or the negative exponent property. This says that a negative exponent means the reciprocal of the positive exponent. So a to the power of n. So we have like 3 to the power of negative 4. That means, according to this rule, 1 over 3 to the positive 4, which we could expand as like 1 times 3 times 3 over 3 times 3 times 3 times 3, get a value for that. Okay, so where is this coming from? The negative exponent means the reciprocal of the positive exponent. What? Okay, well, let's see. So we're again going to use the quotient rule. So let's show why 3 to the power of negative 4 is equal to 1 divided by 3 to the power of positive 4. And to do that, I'm going to use this expression, 3 to the power of 2 divided by 3 to the power of 6. Now, the quotient rule says that that should have a value of 3 to the 2 minus 6 power. Because whenever we're dividing powers with the same base, we can keep the base and then subtract the exponents, 2 minus 6. So this has a value of 3 to the negative 4. But then let's also expand this out. This is 3 times 3 divided by 3 times 3 times 3 times 3 times 3 times 3. We know when we have a number in the numerator and the denominator, then those divided away to 1, we can like cancel them out, right? Because those are just 1. And then to simplify here, now I have just 1 in the numerator, and I have 4 3's in the denominator. Thus, this is 1 over 3 to the power of 4. Okay, so 3 to the negative 4th power is equal to 1 over 3 to the 4th power. The reciprocal, we should know this word. The reciprocal means the flip, right? When you flip over the fraction bar. So for an example of what this looks like, we often kind of math, grammar, one of those things. We don't like having negative exponents because, you know, really what does a negative exponent mean? It means the reciprocal of a positive exponent, but it's kind of weird. So we like to go from a negative exponent form to a positive exponent. So here I have 7 to the power of negative 2. That is going to be equal to, again, the reciprocal of the positive. Thus, it is equal to 1 over or divided by 7 to the power of 2. Okay, and that is equal to 1 divided by 7 times 7, which is 149, if we want to find the value of it. Awesome. So you try that. Get 2 to the negative 1st power into an equivalent power with a positive exponent. Great. And so 2 to the negative 1st power is equal to 1 divided by 2 to the positive 1st power. 2 to the 1st power is just 2, so this is equivalent to 1/2. Great. And now let's just look at some examples of combining all the properties together. So here I have 5 times v to the negative 4th power. The directions say to write the powers as the equivalent simplified positive powers. Okay, so 5 is just a number. It's not being raised to any power. I'm going to leave it as is. But then I have v to the negative 4th power. V to the negative 4th power, that is equivalent to 1 over v to the positive 4th power. That 5 is equivalent to 5 over 1. So we get 5 over v to the 4th power. Okay, so this and this, those are equivalent expressions. And then for the second one, we have 2 to the power of 4 divided by 2 to the power of negative 3. We could do this a few ways, but one way of doing it is just using the quotient rule. So the quotient rule says when we're dividing, you keep the base and then you subtract the exponents. So we have 4 minus negative 3. What is 4 minus negative 3? Yep, that's positive 7, because that's the same thing as 4 plus 3. So we get 2 to the power of 7. Another way of showing that this is equivalent to 2 to the positive 7, 2 to the 7th power, is here we have 2 to the negative 3 in the denominator. So just to like separate this out, this is like 1 over 2 to the negative 3 in the denominator. So then that's equivalent to 2 to the 4th times 2 to the positive 3, because a negative exponent is equivalent to the reciprocal of the positive exponent. So we just flip it over the bar, we make the exponent positive. And our powers of products rule tells us that this is 2 to the power of 7. Awesome. Okay, so now you give this last one a try. We have 7 to the negative 4th power times 7 to the 3rd power. So we're going to need to use the product of powers rules when we're multiplying to multiply these powers. And then remember, we want it in the positive power form. Great, so 7 to the power of negative 4 times 7 to the power of 3. Our product of power rules says that we keep the base, we do negative 4 plus 3. So that gives us 7 to the power of negative 1. And then we know 7 to the power of negative 1 is equivalent to 1 divided by 7 to the 1st power, which is just 1/7. Great. Awesome. Those are all the exponent and power properties. Great job, everyone.